Hello everyone, my name is Ruben Baidon and today I'm gonna show you my argumentative oral exam. Well, for the first question, the unit operation selected that I think can be optimized to increase the performance of the process, specifically recovery and or purity, is bed milling. In literature, it has been found that alkali acid extraction for beta-glucans usually obtain high percentages of purity and recovery, as reported by Penkumsri in 2016. So, in order to obtain a high concentration of beta glucan pellet, the most important step is an efficient cell rupture. In the laboratory practice, bead milling was carried out by adding glass beads to a vacuum tube and vortexing the sample in order to lysate the yeast cells, but we only obtain an 18% of purity and zero point zero 0.03 of yield. This might have happened because the cells were not lysed and were retained at the filtration step, and also because of the water composition of the Saccharomyces cerevisiae sample. To upgrade these results of purity or even recovery, a blender could have been used in the laboratory, which would have lysated most of the sample, and more beta glucans would have been obtained for the extraction or increasing the duration time of the bed milling. Also, a precise control of the pH during the process should be carried out. As mentioned in an investigation by Feynman in 2003, extreme pH values cause the degradation of beta glucans, generating a lower yield and purity. At an industrial level, this case probably would not have happened. If a good selection of the bed mill is carried out by knowing the flow in which it will work, the diameters of the glass beads for the cell rupture, and the chamber volume, a high purity or recovery can be achieved. I would just like also to add a recommendation, which is that, as I mentioned before, the usage of strong alkaline and acid solutions can degrade the beta glucans molecule. So another extraction process can be done like sonication, ultrasound, or enzymatic, which are widely used at a larger scale. One key factor that affects the sizing of the bioprocess for the extraction of beta glucans from spent brewer yeast is the bioreactor selection. Sometimes a couple of unit operations have to be done in a single step, like in the pretreatment or the alkali acid extraction. During the alkali acid extraction, heating up to 80 degrees Celsius is needed, as well as homogenization, cooling down, and pH control. This can be optimized by using a single bioreactor with the capacity of heating, cooling, incubating, and mixing in the same equipment. Not only do you spend less money in different reactors, but also the energy consumption and environmental impact of the process will be positive. To maximize the yield and efficiency, a standardized protocol has to be done in order to work as a continuous reactor, as well as making sure that every single accessory of the reactor works correctly for the process to be done precisely and obtain a maximum yield possible, which is what we want. Finally, bioseparation processes can negatively impact our environment in various different ways. One of these ways is the high waste of water. I mentioned this because in my protocol for this challenge, there were three washing steps, which were repeated three times each, meaning a total of nine different washing steps in the process. This can be seen in the following floated diagram for our challenge. And at the laboratory scale, these washes consisted of 20 milliliters for the pellet concentration, ranging between 1 to 3 grams, making it a total of 180 milliliters of water down the drain. If we scale up these proportions to an industrial level, where we have over 100 kilograms of yeast, this could mean a waste of around 20,000 liters of water. This can be minimized by using less water in the washes, but just enough in order to carry out the following unit operation without a flaw. This was evaluated in the challenge protocol by reducing the, the water volume from the washes from 20 milliliters all the way down to 10 milliliters, where in both ways it was possible to centrifuge and obtain the pellet without any adversity. This can reduce the water usage up to 50%, and by trial and error, it could be reduced even a little bit more, and also save some time uh, of the bioprocess. In addition, sometimes this water is not contaminated, so instead of wasting this water by throwing it away, it can be used for crop irrigation, the same way Cervecería Colima uh, uses its treated wastewaters. And that will be it. Thank you so much for your time.